So Finn's first degree was English literature, and so it's interesting that his presentation was about that, stories from literature. And my first degree was mathematical physics with astrophysics, so I'm going to be looking at insight from that perspective. What drew me to that was I wanted to know the meaning of the life, the universe and everything. And I thought that physics was the answer, that I would then know how the universe worked and where my place was in that universe. But I was disappointed, and that wasn't what happened. So then after various kind of convolutions, I follow this path now as a Buddhist, and I think that's a continuation of that path, to have a sense of the meaning of life, the universe and everything. And I think this one has got a good chance of fulfilling that desire. So I just wanted to share a few thoughts with you about what our reality actually is from a physics perspective, and also how that's reflected in our experience of meditation. So we'll have a go. So the common perception of experiencing objects is that it's solid, separate and permanent. So for example, this flask here seems pretty solid, yeah? It's sort of separate. I can put it down, separate from me, now separate from the table. Yeah. And if I leave it there, it's going to stay there in that sense. It's permanent. And this is kind of how we're evolved, if you like, to perceive the objects around us and to perceive our experience. So we see ourselves as kind of solid, separate things. I mean, I feel quite solid, I have to say. I feel like I'm kind of separate from all of you. And, I imagine I'm going to live forever, like most of us do, So the idea of dying often doesn't, well, it does because I'm a Buddhist, but often for a lot of us, it doesn't pop into our minds. We don't imagine that we're going to die or our loved ones are going to die until it happens. And then it's a horrendous shock because, we have this thing that we imagine that things are going to last forever. On a morning at home, I have my cup of coffee in this wonderful Harry Potter mug that I got from Warner Brothers Studios, and I imagine that will last forever. But one day I'll drop it on the floor and it'll smash, and I'll be absolutely devastated. But if I recognise that the true state of that mug is that it will be smashed one day, I can really appreciate it as a whole mug every morning when I drink my coffee out of it. Yeah? So this idea of things not being permanent and us dying and things breaking doesn't have to be a really negative thing. It can be a real motivation to really appreciate who we have here and that we're here. And then if we look at science, like the scientific view of experience, and particularly objects, is that they're mainly space. So they seem really solid, don't they? But actually, it's mainly space, and I'll talk a little bit more after that. And also, science tells us that everything is really interdependent and interconnected, although it doesn't feel that way. And obviously, everything's impermanent. Things are changing all the time, even though if we like to perceive them, or if we feel safer to perceive them as permanent. So we'll just explore this through this PowerPoint, and then come back to it at the end for you to kind of reflect on the experience of reality is and what you think. So I think a big culprit in this is visual perception. So as human beings, it seems to be like our most dominant sense. And we are evolved to see objects and perceive objects as solid objects, separate and permanent, and independent of each other. That's how we see an object. I see that as a solid thing that's separate from the things around it. But I often reflect on, if I close my eyes, do I feel as solid? Do I feel as separate? And do I feel as kind of permanent? If I close my eyes, if you'd like to just do that now. And we did this a bit in the body scan, like if you explore the boundary between yourself and your environment with your eyes closed, to me it doesn't feel so separate as when I open my eyes and look at myself, and I can see, say if I look at my hand, a distinct line between myself and the space surrounding my hand. And if I close my eyes and tune into my body, I can feel lots of things changing. I can feel the breathing, I have a sense of the blood pumping around. So it doesn't seem as if it's kind of permanent, you know, it's changing all the time. So if you want to open your eyes again. And then if we look at colour, see, colour is very interesting because we think of colour as real. You know, we perceive a colour like it's a colour blue or a colour green. Like for us, for example, in the English language, we have like orange, pink, and where is it? Here. We have red, pink, orange, and brown, which are actually all the same kind of hue, but we see them as separate colours. So we see orange as a separate colour from brown, and brown is a separate colour from pink. But in some languages, there's just one word, so it's seen as one colour, you know, because our perception of colour is conditioned by our language. So when we're kids, we're told, oh, well, that one's pink and that one's orange. So we learn to perceive them separately, whereas in other cultures, it's just seen as one colour. And there's the reverse as well. Russians will see a distinction between what we call dark blue and light blue. So whereas we just see one colour blue, they'd see two separate colours. So that's really interesting, isn't it? How our language conditions our perception, and that's just one example of colour. You know, you can imagine that that's, you know, in all areas of perception and experience, that from different cultures we're kind of experiencing things in different ways. And then there's this wonderful colour constancy. And there's that dress. Now then, what colour is that dress? Who sees it? Huh?
Blue and gold.
Blue and gold? Yeah. Blue and black?
Blue and gold.
Yeah. Does anyone see a white dress?
I know it's a white dress, but I still don't see it.
You don't see it as a white dress? No, so no one here sees it as a white dress? I showed it to the guys in the office on Tuesday, and Helen and Jane see it as a white and gold dress, and which is actually a white and gold dress. That's, you know, in reality it is a white and gold dress. So, and some people see it as a blue and black dress. And it's a bit disappointing, this, because I did it in Italy the other week as well, and half the people in the Italian group saw it as white and gold, and the other half saw it as blue and black.
I read that a lot of it's to do with context, and we're against a blue wall.
I'll come on to that in a minute, yeah. So that was quite fun, because the two groups of Italians were going, no, it's white, no, it's blue. But anyway, so younger people apparently tend to see it more as white and gold. My daughter sees it as white and gold. But what it's to do with? It's to do with the usual lighting conditions that we're used to. So it's conditioned again. So from that photograph, there's not enough information for the brain to figure out what the lighting conditions are. So it just makes an assumption. And because of our previous condition and the lighting conditions we're used to from our past experience, we see it as blue and black. But other people who have other lighting conditions conditioned into them in their past see it as a white and gold dress. So something that seems as kind of real as colour, you know, you can have a massive misperception like that. And what it's to do with is that we've evolved so that we see colours in relation to the context, to the colours around it. So, depends on different lighting conditions. Because actually in different lighting conditions, different wavelengths of radiation come into your eye. But, you know, an apple, you always want to see an apple as green. You don't really want to see it as blue because you might be a bit confused. So we've evolved to sort of recognise the apple within the context of how it's lit and what's around it, and see it as green always. Unless it's the red apple, of course, in which we can see it red. So that's quite interesting, isn't it? That our prior experience conditions the colour that we see in that dress. And it is actually a white and gold dress. The blue bits are white and the black bits, the lacy bits, are gold. ready. Let's go back. It's conditioned. Oops. Address. Here we go. So I was listening to a programme on Radio 4. It was all in the mind, and they were talking about perception. And what they were saying there is that from what you see around you, 10% is based. 10%, all the data that's used to form the visual imagery that you see, 10% is coming in through your eyes. 90% is from already known in your brain. Yeah. So that's so like, you know, we're kind of going on the information that's going in and then building the rest as we go, which is quite interesting, isn't it? So like, we really are creating our own visual reality. There is something out there, and that's information about that is coming into the eye, but a lot of that is kind of, that's added to, that 10% is added to by 90%, which is based on what we've seen previously. And an example of this is their stories of when the big ships arrived in the New World. The natives standing on the beach couldn't see them because it was outside the realm of what they visually perceived before. So they couldn't actually see the ships in the harbour. And there's stories about a shaman standing on the beach and having a sense that there was something there but not being able to see it. And he stood there day after day and eventually did see them, apparently. But that's really interesting, isn't it? And one of the things that I think about is aliens, you know? Like, if there was an alien, would it be on an alien ship, would it be beyond our range of visual perception because we've not seen anything like it before? So they could be among us, they could be sitting here, but we don't see them. That's quite interesting, isn't it? And just the physics of our eyes limits what we can perceive, so we can see a tiny bit of visual light within the whole electromagnetic spectrum. So we can't see in the dark, for example. Some creatures have eyes that are evolved to see in the dark, but not us. So, you know, with the range of signals that each of our senses can actually perceive, that limits actually what we're able to perceive from the environment around us. And we've evolved over the years, you know, so for us, this like range of kind of visual light really helps us navigate our way around the world, so we can experience that. But for other creatures, other senses, it's useful for them to navigate around the world. I often think of my dogs. I have 3 dogs and they all chase balls, and they do use their eyes, but if they lose the ball, they use their nose, they don't use their eyes. So like, I have this kind of impression of the environment around me because of what I see, and I wonder what impression they have about the environment around them because of what they smell, you know. So this is the things I wonder about when I'm walking the dogs. But how their experience, because of how they're evolved and how they perceive the reality around them, which objectively would be the same as the reality around me, they perceive that a lot more differently than I do because of their senses being slightly different. So then we ask physics, you know, what is really out there? So this flask is made up of molecules and masses of space in between the different molecules. And the molecules are made of atoms with masses and masses of space between the atoms. And the atoms are made of a nucleus with electrons whizzing around them. But masses and masses of space, you know, like a solar system, like, you know, the distance that the sun is from the earth, that kind of level of space. You know, like if you imagine the nucleus being the sun and the electrons being the earth, masses and masses of space. And then the electrons, you know, under certain circumstances, they don't behave like particles, they behave like waves. They behave, you know, like waves going across water, like a wave packet of energy going across water. So electrons, which, you know, little particles whizzing around neutrons, you know, they behave as waves, so they can be, you know, they are recognised to be packets of energy as well. And then if you look at the nucleus of each atom, made up of protons and neutrons, the protons and neutrons are made up of other little bits, and as they get smaller, they behave like energy, they behave like packets of energy, they behave like waves. So what have we got really? You know, what is this made of? It's made of sort of vibrating energy waves and loads and loads and loads of space. Doesn't seem like it though, does it? But that's what physics would tell us. And then we've got Einstein's equation, E equals mc squared. So energy is mass times the speed of light squared. So like, that just is showing that, so the mass of an electron times by the speed of light squared is the energy. So what is this? Is it like a hologram of vibrating energy? Yeah? And Pema Chodron talks about this in her book, Start Where You Are. You know, it all seems so real and solid and separate, doesn't it? But actually, it's a bit like a hologram. We perceive it in a different way, you know. And like this sense of touch, like this feels really solid and real to me. But actually, I'm not even touching it. There's electrostatic repulsive forces, so that are between the top layers of electrons in my finger and the top layers of electrons in there that are repelling it. And I sense that as a sense of touch. So, you know, even there's no touch actually going on. I'm just experiencing a repulsive force. And then colour, you know, colour is just, so the light coming in from here hits this, and a lot of the colours are absorbed, but the colours making up the colour purple are reflected from this and go into my eye, so I see the colour purple. So, you know, it's not that this material is, I see it as purple, but it's just that it reflects purple light and absorbs all the other colours. You know, so that's what science tells us. So I think, for me, it's helpful to kind of reflect on these things as I go about my world. And sometimes when I'm meditating and I've got kind of my eyes open as I do, you know, I have this sense of, you know, what's really there. This like idea comes across my mind. What's really there? I can see all this stuff, but, you know, I have this sense that that's not what's really there. And then this idea of interdependence. So it was someone on an MSc program who was talking about this, about ant colonies. So in biology, like if we see ants, you know, like the movie Ants, we anthropomorphise them, don't we? So we see each ant as a little separate character. So if you were sat watching the ants, you know, cutting up leaves and moving about and what they do, you'd be going, oh look, that one's doing this and this one's doing that. But in biology, often an ant colony is considered as a single organism. So some biologists would say that was a single organism rather than many different organisms. And we can look at ourselves like that, can't we? You know, like we think that we're really separate, but none of us can survive on our own. We need each other to survive, don't we? So are we really that separate? Or are we more of a colony of ants helping each other to survive? And I don't know whether you've seen the film Avatar, but that's the main concept there, isn't it? That actually the whole planet was just one organism. Yeah, and actually they weren't separate, they were all interrelated and interconnected. And if we had a bit more of that kind of a view, we might be a bit more environmentally friendly, we might look after each other a bit better as well. And then this is brilliant, Pauli's exclusion principle. I remember this from my degree, but Brian Cox talked about it on one of his programs. And this is like, so you've got this is like a Newtonian traditional model of an atom. So the blue and red bits in the middle are the nucleus of protons and neutrons. And then the kind of, the three bits that are orbiting are the electrons around the outside. Now the electrons whiz around at a particular energy level. Yeah? So like, for example, for a fluorescent light, you'd have sort of the atoms in the fluorescent light. And when electricity comes through, the electricity excites the electron from a lower energy level to a higher energy level. And then when they drop back down, they emit energy in the form of light. So that's how fluorescent light works. Yeah? So all the time, all these atoms in our bodies, in everything, have got these electrons whizzing around them, moving from between these different energy levels. They get stimulated and then move up to a higher energy level and they drop back down again. Now, the physics of Pauli's exclusion principle leads you to the conclusion that no two electrons in the whole of the universe can be at the same energy level. Right? So when an electron in my body moves from one energy level to the other energy level, somehow does it know all the other energy levels of all the other electrons across the universe? Right? If that's true, then why are we interconnected? Yeah? So this is quite an interesting thing to reflect on as well, you know. And then if we reflect on the millions of causes and conditions that have led us to being here, if we take an example of food, so for example the bread that we're going to have at soup tonight, so someone's making that bread today, you know, and then someone's grown the wheat from which the flour has come, and someone's processed the yeast that's gone into that. And, you know, years and years ago, the first humans, you know, mixed up some ground wheat with some yeast and made the first bread. And many years before that, you know, the first humans, you know, said, oh, let's take this grass seed and plant it, and sort of started to grow wheat. Going back even further, sort of hunter-gatherer societies. And like, we're all the result of this process of evolution that goes back to the first humans, that goes back beyond that to the first living organisms. And so all these causes and conditions have had to be in place all through time for us to actually get here at this time. Yeah? So billions, innumerable, infinite numbers of causes and conditions. And then you can go back even further. So like the Earth, when it formed, it's just at the right distance from the sun, so that water's liquid. And it's got the right chemical compositions in the Earth when it formed, that it can have like carbon and hydrogen and oxygen, particularly carbon and oxygen, so that, you know, we can have water and carbon-based life. And that the dust from which the solar system formed, so from which the Earth formed, it's got these wonderful chemicals in them already, these wonderful atoms in them already, were formed in a star, an earlier generation of stars. So you had a first generation of stars that burned hydrogen to form these heavier elements like carbon and oxygen, and then that exploded at the end of its life as a supernova, and then from that gas cloud, the solar system formed with our sun in the middle, our Earth. Like all these causes and conditions going back in so far in time to the Big Bang. So as you know, the universe apparently started from nothing, from a singularity that just appeared. This is a singularity that is infinitesimally small and infinitely dense. And then it just went bang and gradually got bigger and bigger and bigger. And the thing about the Big Bang is that there was no time started then as well as we conceptualize it, and space started then as we conceptualize it. So the Big Bang didn't happen in time and space as we conceptualize it. It's beyond time and space. So that, you know, so all that, you know, what set that in off? You know, what was the cause and condition there? Is it just one? Are there infinite numbers of them? You know, all over the place. These universes that start with the Big Bang and expand. I mean, it's amazing when you think about it. And I think what's really useful is, you know, when you're getting all caught up in your stuff, you know, like someone's just pissed you off and you're really in a grump. You know, like, this is some perspective, isn't it? You know, in the grand scheme of things, it doesn't really matter. So I think it can be really helpful to and also to understand that there are millions and millions of causes and conditions that lead to any circumstance happening. So just briefly on impermanence, so everything is changing. I talked about that before, didn't I? That, you know, in our Western society, we all imagine that we're going to live forever, and we all imagine that all those that we love are going to live forever as well. So, which is why the experience of death is so traumatic, because it's such a surprise. Whereas in other cultures, it's reflected on a regular basis. So in Buddhism, for example, one of the daily reflections is a reflection on death and impermanence. So, you know, I've kind of over the years come to a bit more to terms with the fact that I will die, you know, and boy, it makes me grateful when I wake up in the morning alive, and that, you know, and that my dogs will die, and that my, you know, husband will die, and that all the people in my life will die. In 100 years, we'll all be dead, won't we? You know, but then it can make you really grateful for them while they're here. But it's a really common sense thing to reflect on, because it's true, you know, that everything's changing all the time and everyone's going to die. Just don't like to face it, because it can be a bit uncomfortable. So particularly in our Western culture, we ignore it. Mountains, they seem pretty solid, don't they? And they are for quite a long time, but you have these tectonic plates shifting all the time. So mountains, you know, the tectonic plate comes along and the mountain gets higher. And then if you've ever been to Ayers Rock in Australia, that was a mountain once, it's been eroded away and is now kind of a lump, you know, kind of a rounded lump. And as I say, you know, all these objects that looks, you know, permanent, it's like a vibrating mass of energy. From a physics perspective, it could be, you know, understood that way. So, and this human body, you know, we're holograms of vibrating energy. If you close your eyes, you get a sense of that, don't you? It feels more, you know, like you just close your eyes. You could maybe relate to that. But with the eyes open, when you're looking at your hand, you think, nah, is a hand there? And the sense of touch as well. You know? So it seems solid. And then, as I say, we imagine ourselves separate. And we've talked about interdependence, haven't we? That we can't survive on our own. You know, like if you were on a desert island on your own, you maybe wouldn't survive very long. And if you did, it wouldn't be very pleasant. You know, we need each other. We need all the kind of resources that we work together to gather, to feed ourselves, to clothe ourselves, to house ourselves. And then again, this Pauli exclusion principle that all these electrons seem to know where all the other electrons are doing across the universe. And then we feel quite permanent, don't we? But in our body, our cells are being replaced all the time. So over a period of 7 to 10 years, practically every single cell in the body is replaced. So we don't have the same bodies that we had 10 years ago, which I think is a bit of a shame, really, isn't it? So, you know, so this body is changing all the time. And it's like not a solid or a